All right, looks like we are broadcasting live. I'll wait a few minutes for people to come in here, and then we'll get started. You know what? I'm just going to get started, and if anyone wants to hear my stuff, you can listen to episode 57 of the Local Maximum later. All right, we'll start in 5. Just get everything over to the right sections. Okay. Welcome, everyone. Welcome to the Local Maximum. This is episode 57. I'm your host, Max Sklar. Today is, well, this is an interesting day because this is the first time that I'm doing a solo show. It's the first solo show I've done in a while. And it's the first time that I'm doing a solo show with a live stream. So it might be a little distracting that I'm seeing myself, but we'll see how this goes. Let's see if I know everyone can see that I'm drinking out of the Local Maximum mug. All right, so what's on tap for today? I remember when data scientist was considered like the hottest title in tech. Ugh, titles, hate them. But I got to say, it's still pretty hot. But there's an article called Data Science is Different Now, which is a story about change in the workplace. And we're going to keep on top of that today. And then I'm going to talk about making analogies and how machine learning engineers have turned that into an algorithm called the nearest neighbor algorithm. If you are a practitioner of machine learning or AI, you'll know the nearest neighbor algorithm very well, but I have some things to say about it, having used it. We're going to start with some philosophy and logic. What is the analogy argument and why does it work? And then you're going to hear about how companies like Foursquare use it in their technology and how it's used in products that you use every day. So yes, another solo show of the Local Maximum. I haven't done a solo show in a while, mainly because I have so many guests who accept my offer to be on the Local Maximum, as well as so much stuff I want to bring Aaron, my co-host, on to discuss. And so this has fallen by the wayside, but I do want to do more solo shows in the future. I have a couple of ideas. One is an analysis of the Electoral College using the concepts that we uncovered on the social choice theory episodes. And another is a discussion of podcasting itself as a social medium, which is really interesting if you compare it to, say, Twitter and Facebook. So call it my podcasting manifesto, maybe. So if you have an idea on a solo show that you would like to see, email me localmaxradio@gmail.com. All right. So here's the deal about the blog article by Vicky Boykis. I will put it on the show notes page, localmaxradio.com/57. So I personally graduated from NYU with a degree in information systems in 2011. And it was basically half of a business degree and half of a computer science degree. And the nice thing about that was that it gave me some flexibility. I finished my master's degree essentially in 18 months. And I already had the computer science degree. I already had the software engineering job experience. I didn't need a full one on that. And then it enabled me to expand in business courses, which were, some of them were machine learning related, and many of them were technology related. So that I finished about 18 months. I graduate in 2011, and Foursquare is looking for a data scientist. And I would go on to work there for about 7 years, eventually working with the founder on experimental new products. See episode 7 with Dennis Crowley. And then I expanded it to my last project, which was attribution, where there was which was extremely heavy on mathematical modeling, on causality modeling. See episode 31 with Shirin Mojarrad. But the thing is, when I joined the company in 2011, I didn't receive that title of data scientist. It was confusing because a lot of people there thought I was a data scientist. People who were outside called me a data scientist, but they ended up giving that title to people with a slightly different background than me. So I put on my LinkedIn account the most accurate description of what I was doing that I could think of, which was machine learning engineer. And basically that would mean building AI into consumer products for the purposes of things like building the recommendation engine, inferring information about users, finding patterns in data, that sort of thing. And it's not always machine learning. Sometimes it's getting little heuristics and tricks to try to get things to work. But it's all in the area of building smart software, making the software look and feel really smart and act really smart. And machine learning is often a big part of that. And I spent a lot of time, researching machine learning methods, so I had a good idea of what was going on there. So yeah, now I was doing a lot of the same stuff as the data scientist. That should be pointed out. So especially at first, there was all this analyst work that needed to be done. We needed to set up data pipelines. We needed to look at all the log data actions that users would take in the Foursquare app and kind of summarize it for the executive team. And well, maybe there's something similar going on now at my new job with Luminary as it relates to podcasts, but I'll have to cover that in the future. But look, as the company grew, all of these roles started to pop out. They started to disambiguate with each other. And this is something that's interesting that happens when an organization grows. Machine learning engineer, which honestly I thought I made up, but it's a thing now. There's the data engineer, which works to make sure the pipeline is working as good as it could be. The data scientist, which does a lot of the offline analysis. And when the media comes on that year and says data scientist is the hottest job, it's sort of like, well, what about all these other roles? And then you realize that when the media says data scientist, they're actually talking about all of these roles: data engineer, machine learning engineer. They don't know from data scientist or machine learning engineer or anything like that. So when someone asks me, how can I become a data scientist? First, I have to further ask and see what they're talking about. Do they want to be product focused? Do they want to be algorithm focused? Do they want to be statistically focused, analytics focused, basic research? All these things. I say, give me some examples of products you'd like to work on. And depending on what they say, or maybe they need some help figuring out which of the four, you kind of get different answers. And so, but it is a very confusing situation out there. I know one coworker of mine once exclaimed, like, there's this other company and they're calling these people data scientists and all they do is work in Excel, like, how dare they? But that's what happens. There's a little bit of title, there's no laws anywhere telling people what titles they have to give, what roles. I mean, that's why we have this crazy thing in startup world where someone can be like chief ninja or whatever that is. So that's what happens. And I know not everyone in this particular audience is in one of these particular roles like data scientists, but I'm wondering if any of you out there have experienced the same thing in your field, whether it's marketing or sales or another type of engineering or anything like that. Because I have a feeling that it's something that happens in a lot of different areas in the workplace where job titles you find don't mean the same thing that they meant 5 years ago. Now, we know that the media can't tell the difference between all of these, but as I said, there's confusion within the industry as well. And if you apply for the role of data scientist at different companies, you'll end up with a completely different job, as I just outlined. So you really have to look into what they're doing. So that brought me to this article, why you shouldn't be a data science generalist. And if you're more interested in all of the different jobs around data science, machine learning engineer, then I would highly recommend this article. It's just very good at organizing it. I will put it on the show notes page, localmaxradio.com/57, why you shouldn't be a data science generalist. Okay, so coming back to the Data Science is Different Now article by Vicky Boykis, we look at some of the history here. I think that NYU got its master's in the data science program back in 2012. So when I was there, that wasn't even an option. So that's crazy how fast this moves. Like the whole departments and master's degrees start springing up. And then there's tons of changes around the tools we use, but there's a lot of things that have remained constant. So for example, people often warn you like, hey, anything you learn now will go out of date. No, that's not always true. Math doesn't go out of fashion. I can tell you that. So don't worry about learning math. It will be useful. There's still a lot of Python and R. So that stuff is not going away anytime soon. And even if one day in 10 years, like Python wanes in popularity and something starts to replace it, that something will have very similar functionality to Python. So all of the skills will transfer over very well. And actually, some of the algorithms we use, and I'll talk in a few minutes about the nearest neighbor algorithm, those get updated, but they don't so much go out of style. Like logistic regression doesn't go out of style. Neural networks have been around for a while. Nearest neighbor doesn't go out of style. But there's a lot of novel work. There's sort of a difference on where you implement them. I think that the deep learning, and with TensorFlow, there are certain key areas when you're building products where that's a good idea for it to be implemented. But I think that there's a lot of novel work that a practitioner can do in applying and adopting these algorithms to new situations. So, for example, I wrote some papers a few years ago, one on the Dirichlet distribution, and on calculating the optimal Dirichlet distribution very quickly. I don't expect anyone to know what I'm talking about, but I'll put that online, and things like that. There's some more papers that I want to write too, but oftentimes you find that applying these things to new problems, you learn something new about them. So the issue now, and I'll quote directly from the article, the problem is an oversupply of junior data scientists hoping to enter the industry and mismatched expectations on what they can hope to find once they do get that coveted title of data scientist. Now, this is somewhat true. I don't want to discourage anyone, though, who's pursuing a career in data science or machine learning, because there's a lot of very exciting things going on and the job market is huge. But let's talk about what the specific issue that the article is talking about right now. So there's some convincing evidence here that there are huge numbers of resumes that come in for new jobs, university classes with huge numbers of people in them for data science degrees. There are boot camps popping up all over the place. I talk with them sometimes, where people can get certifications after 6 weeks or so. A lot of people want this job, and there's a lot of cool things about this job. You're like, oh, you can pull patterns out of data and figure out what's going on with everything. Something. Deep learning AI was an interesting example that was given, because that was Andrew Ng from Stanford's company. And they said that this is an 80-hour-a-week job and got thousands of resumes. That's crazy to me. Insane. Never take an engineering job where they say 80 hours a week. I think, maybe I can hustle around in meetings and doing deals for that long, but I definitely not for reading and coding. The article continues. This wasn't the case even 3-4 years ago, but now that data science has changed from a buzzword to something even larger, companies outside of Silicon Valley bubble hire for, positions not only become more codified, but with more rigorous entry requirements that will prefer people with previous data science experience every time. As many blog posts point out, you won't necessarily land your dream job on the first try. As a result, the market can be very hard and very discouraging for the flood of beginners. So I actually don't think this is something new, but people may need to be even more flexible. I mean, when I entered the job market as an undergrad a long time ago, I couldn't find a role in machine learning or data science. I mean, this is way back in 2006. But after a while, you can get the experience through a more generalist kind of engineering job. So that's why I kind of approached it from the area of software engineering. I'm going to build your software. I'm going to be a generalist coder. So many companies need that. You'll find companies out there that are willing to give a new person a chance. And because that market is huge, it's not really affected by the glut of a single subgroup. And then ultimately you can find some job that kind of combines the two. Well, I'm going to work adjacent to a machine learning engineer, and then try to get in that way. And then sometimes you can't, sometimes it's hard when you're in one company and you're like, well, I want to be the machine learning engineer, not just work with them. It's hard to make that jump over. Sometimes you have to work with them at that company for a while and then apply to a machine learning engineer job at a different company so that they know that's what you're doing. It kind of sucks that's the case. You kind of wish sometimes you should be able to move within one company, but I found that often it's a lot easier just to move over. And that's what I hear a lot. So any job you take will get you experience. It might not be what you want ultimately, but then you can kind of move around after a reasonable amount of time. And so, yeah, that's what I have to say about that. Let me know what you think. localmaxradio@gmail.com. I want to see what the other perspectives are out there. And I know we all get a lot of questions for people who are, asking for advice on their career, and I want to make sure that I'm giving good advice. So I want to hear more experiences around that. So the second thing in this article is again about the different types of tasks that data scientists do out there. And a lot of them are not as glamorous. A lot of people spend a lot of time cleaning their data. Yeah, it's true. Getting rid of like all the spam, all the crap. If you're dealing with NLP, natural language processing, there's the whole question of, I think that's Chris Conception, episode 23 on the local maximum. We talk about how, there's all these words you want to throw out because they're not very meaningful words if you're trying to get information from a document. And so data cleaning is a huge one. Productionizing, evaluating. I think evaluating your models is really important. That's what I try to spend most of my time on, is thinking about how evaluating the model is taking sense. In other words, how are you going to grade the homework? Because ultimately, particularly if you're working for a company, what you're building is integral to the product. It's integral to the company's bottom line. And so you could keep building more and more and more sophisticated stuff. But what you really want to focus on is, okay, how does this affect my company's product? How does this affect my company's bottom line? And the better you're able to answer that question, the better even small changes to the model are going to have that targeted impact that you want. And so if you're thinking about if you're a machine learning engineer thinking about where to invest your time, I always think that's a good one. So here's the part in the article which seems very unfair to, not the article is unfair, but a trend that is unfair. That this trend has led to a severe degree of job title deflation for data scientists. So remember, before I said that the job title is thrown around in a lot of different areas. Now they're saying job title deflation, where because of the prestige of the data scientist job title, companies like Lyft will hire for data science job titles, but with data science skill sets, data analyst skill sets, resulting in an even more skewed picture of what constitutes a data science job and exactly how many of them are available for new entrants. The article goes on, we as senior practitioners, journalist managers, industry conference speakers, HR managers, writing job recs, just have not done a great job keeping up with this extremely important piece of the puzzle. So for those of you out there, and by the way, I know I just got mentioned in Data Science at Home. Love that podcast. Thanks for glad to support that show. And so for those of you coming on, we could think about how to deal with this situation. And I think, honestly, I think the data scientist term is mostly a shortcut term for outsiders. I think for us who are going to be insiders, we need to be a little bit more specific about what exactly we're working on. So I think that's something we should be thinking about for job descriptions. Another thing in terms of getting demand, if you're someone new, focus on other skills in addition to your data science or machine learning engineering skills that can go along with what you're doing. So for example, if you have software engineering skills, like I said, perfect, you'll get in. And then for me, find other outlets to spread the word on this on, like podcasting. So, all right, that's what I have to say about the data science job title and the prospects for new data science engineers. For those of you who are working on it, well, first of all, you're listening to this podcast, so you're already in like the top 5%. So I would encourage you to keep going and reach out to me if you have any questions. localmaxradio@gmail.com. Even if it's a very in-demand job, it's always hard to find that entry level. So I have a lot of what do I want to say? Sympathy, empathy for someone going through that experience now. And I hope you make it. And there are a lot of ways to make it because the job ultimately is in demand. All right, let's talk about the nearest neighbor algorithm. I want to start with something philosophical. Like, how do we know anything? Okay, so you get this from Rene Descartes, right? I think and therefore I am. Cognito ergo sum, as really the only ironclad argument out there for knowing that something is true. Hey, if I'm thinking about this, then I must be some entity. There must be some entity here. So, that's kind of obvious. If there isn't, then what is all this thought about? All right, pretty straightforward. But after that, I think after that, it's hard to have any argument about something being true or something existing that is 100% ironclad proof. So I think a good example of this, I don't know if you've ever been in one of these discussions. They happen late at night. There are these late at night discussions. Oh, wait, hold on. I got to take another drink. There's a lot of talking in these solo shows without breaks. So you have these late at night discussions when someone says, you know, how do I know that I'm not the only real person on Earth? Like maybe everyone else is some kind of robot, but me, and I'm the only conscious person. And I'm just being tricked into believing that everyone else has the same humanness that I do. And for me, I think the way to solve this is, well, one, admit that there can't be any ironclad proof here because, you know, it's not directly testable. If the proposition were true, the world would be the same as it is if the proposition were false. And remember your Bayes, if you have two hypotheses that lead to the same outcome, then you have no way of inferring the right one using Bayes' rule. But number two, I think you can assume that other humans also have a consciousness and a soul, if you believe in that, by an argument from analogy. And the analogy argument basically says, well, I live in this body here. You know, I'm conscious of my surroundings. I'm not a robot. I'm not autonomous. I see other people around. They have the same kind of properties as me. Therefore, I can assume that their experience is similar, or maybe their experience is not entirely similar, but they have an experience. They have a consciousness connected with themselves. And so that's the analogy argument. The analogy argument basically says that, okay, if you have one situation, well, if you have two situations and you have a bunch of things about them that is true in both situations, a bunch of properties that they both have, and then you have, let's say they have 50 properties that they all have in common. And then there's this 51st property that the first one has. Then you think, well, these two things have a lot of these properties in common. So maybe the second thing also has this property. And so you can see it's kind of fuzzy. It's obviously not always true. And there's a little bit of intuition involved in figuring out which properties copy over, but it's not a fallacy. And it's really the main tool that we have, as imperfect as it is, it's the main tool that we have to interact with our world. I mean, everything that you talk about is an argument by analogy. So in this case, the analogy is, well, me and another person out there, we have so much in common. You know, there are so many things that two people in common that you can tell that have different, that have similarities with each other than with an inanimate object. And you could say, well, both have an eyes and nose, a face, both of us move around. We seem to have some similar motivations. We seem to speak language. We seem to have all the properties of an animate object. And so there's kind of this, you just kind of get this sense that, okay, maybe the idea of consciousness copies over to that. So there are more practical applications to this. One is, well, let's not say practical, but one where people actually follow, actually act based on the analogy argument. One is having a bad experience with a product or person. If you have a bad experience with, say, a different brand, then maybe you won't use that brand anymore. You're making an analogy. You're like, well, the last 5 times it didn't work, so this time maybe it also won't work. Or sometimes maybe a person, you know, some people, somebody, there's this idea of having the heebie-jeebies in a certain situation where something is not right. I need to get out of here. And I think what's happening here is you're thinking of bad situations in the past. Maybe you're thinking of other situations from movies or something. You kind of take a look around and your subconscious says, like, there's something similar here that's like a situation in the past that didn't work out well for you. So I think that may be where that feeling of the heebie-jeebies come from. So this idea of making analogies is something that allows us to draw inferences. Oftentimes we draw causal inferences from that. We say there's causality where oftentimes there's only correlation. And that's why the causation correlation thing is such a big problem, because it's we're drawing causations from correlations every single day of our life with everything that we have. So for example, like, well, let's go back to the example of like getting burned from a hot stove, and maybe you see another surface. It's not a stove, but maybe it's glowing. So you might think, okay, this might also be hot too, because it looks similar to the other thing that was hot. So maybe I should be careful before touching it, that sort of thing. So again, the argument by analogy is not a fallacy on its own, but it can be used in fallacious ways. If you listen to political rhetoric, it's full of false arguments by analogy. Usually you take some horrible person in the past or horrible position in the past and you connect it to your opponent, and voila, they're evil now. Arguments by analogy can be swatted away in several ways. So first, you could just show that the analogy is bad, like the latest property doesn't carry over. You can show that, I'm trying to think of an example of that. Well, you could show that the other items with the same properties don't hold the target property. So for example, if I see a stove that's not turned on, I could say, well, it's not the fact that it's a stove that's making it hot. It's the fact that the stove is turned on that's making it hot. And so just by seeing the stove properties doesn't mean that the same things are going to happen if I touch it. But ultimately, like I said, all of our thinking rests on analogies. And the main assumption here, and it's an assumption you really have to make, is that there is some regularity in the universe. If there was no regularity in the universe, then none of this, then nothing would make any sense. You wouldn't have language. You wouldn't have life. So it's not that there's no randomness. It's not that the universe works like clockwork and you can always predict it. That's not saying that God, Einstein said, I don't think God plays dice. Saying that there's some regularity in the universe is not saying that God never plays dice. Could be that God plays dice sometimes, but it's just that there is some non-randomness, some patterns. That's got to be a totally fair assumption. Otherwise, nothing else makes sense. So again, I touch that stove. I see something else that looks hot. Maybe it's glowing red. So I think by analogy not to touch it. So again, it's not an ironclad argument, but it helps us navigate the world through the use of probabilities, even if they are fuzzy probabilities, like the probabilities in our subconscious. And those are the ones that I spoke about in episode 21. So interestingly, in the book Master Algorithm by Pedro Domingo, he categorizes a few different types of machine learning algorithms. And one of them he characterizes as the nearest neighbor algorithm, as an analogy approach to the problem. So what does it mean to learn by analogy? Like, I think that in some ways, all machine learning works by an argument through analogy. So for example, if I can detect a cat or a hot dog in this data set and it works, then I make the analogy, well, this other data set is also images that come from the internet, and it's also images that come from the real world that we live in. So maybe that algorithm will also be able to detect cats and hot dogs from that data set. Why not? If I, well, let's look at language. Like if I speak English to this person and they understand me, then maybe the next person I talk to might understand English as well. Not always, but probably. And like I said, it's, well, not that I said before, but this is kind of, all of this sort of thinking is prone to overfitting, like thinking, okay, the first 5 times I tried a new flavor of ice cream, it was really good. So maybe every time I try a new flavor, it'll be really good. Not so. You can have a really bad one. And secondly, like I said in the article, what was the, there was one we did with overfitting and underfitting. Let me go to the archive here. Right. Episode 16 of The Local Maximum, overfitting toddlers and underfitting curmudgeons. So that was an interesting one. And there we talked about how toddlers are prone to overfit, where they see a few examples of something happening and then assume that all of those examples. One is like, just because someone is taller, they're necessarily older, because I saw a bunch of examples. Well, if I'm 2 or 3 and then I see someone who's 4, they're taller. And then I see someone who's 6, they're taller still. Therefore, maybe I make the analogy that anyone who is taller is also older. And that's an argument by analogy. That's also an inductive argument, and it's totally overfitting. So that's another good example. So I think the nearest neighbor algorithm is the one that comes closest to putting this idea of argument by analogy into practice. So what nearest neighbor algorithm does is you have a bunch of things. Maybe it's information about houses. Maybe it's images of cats. Maybe it's points, latitude, longitude points in the world. And you're trying to say, okay, if these things are closer to each other, then they probably have more in common than if they're farther from each other. So, and then if I have a training set and then I have a new example come in, I look at the closest examples and say, okay, it's probably similar to that. So let's look at the cat example. If I have an image of a cat and then I say, well, this looks very close to these 5 images that I've already seen, and I already know that they're cats, then I could say, okay, this image I will classify as probably being a cat. And so that's how it works. Oftentimes it's called the K nearest neighbor algorithm, because you're looking at the K. K is like a number. Let's say it's 20 nearest neighbor. You're looking at the 20 closest examples to the one that you're trying to figure out. And the examples are the ones that you already know. And then you try to come up with the answer that way. And so that's basically how the nearest neighbor algorithm works in a nutshell. It's one of the easiest ones to understand, and it's used in many of the products that you use every day, I'm sure, on your phone. So there are a few pitfalls when it comes to nearest neighbor algorithms. The first one is known as the curse of dimensionality, and that is that if the number of dimensions is small, in other words, if my points are points on the globe, then that's basically a 2-dimensional space. And then K nearest neighbor works really well. As the number of dimensions increases, I'm not going to ask you to think about 4-dimensional space and 5-dimensional space, but even that works kind of well. If you're thinking about 100-dimensional space, or in the case of images of cats, it could be, 10,000 dimensional space, then it might not work very well, because some of the, some dimensions are going to be far away, some are going to be close, and it's going to be very difficult to determine what that distance function is. And the nearest neighbors might actually be something that's very far away. And then the second thing that's the problem is building the distance function itself. It's a similar related problem, but it's like, okay, we need to have some way of determining how close 2 things are. We need some way of building a distance function. And sometimes it's obvious and sometimes it's not so obvious. And the way it's not so obvious, there are a few things you can do. You can try to learn a distance function, try to find the best one, the one that makes your final model the most predictive. And so that's one way of doing it, but it's not always that easy. And so another thing is it requires a lot of space and indexing, because remember, usually you build a model and the model is kind of like a mathematical function. It's really small, but in this case, you're actually storing all your examples and then you're saying, hey, I want the 20 nearest. And you can't just, go through all of them and find the 20 with the closest distance. You really have to have some data structure in there that indexes that. So that's where some of the kind of the interesting engineering problems come into play when building something like this. I think most people who are proficient in computer science can probably figure it all out. But those are often problems. So I want to talk about an example at Foursquare, which is really interesting, because at Foursquare, we're trying to predict the we were trying to predict, as you know, I don't work there anymore, but we were trying to predict the location you're in, the venue you're at, based on your latitude and longitude. And one of the signals that goes into that, in fact, one of the strongest signals that goes into that is the K nearest neighbor algorithm. And the reason why it works so well is, first of all, points on the center of the Earth, again, that's two-dimensional. So we don't have the curse of dimensionality there. We have the blessing of low dimensionality there. And secondly, so anything where the points actually represent points in space, it works very well too, because in another case, when you have two numbers, like let's suppose you're given someone's height and weight, and you're trying to use those numbers. So you can plot height and weight on a graph, right? And then you have some kind of a map, and you could say, okay, what's my nearest neighbor? But then there's the question of, okay, I don't know if 1 pound of extra weight is the same, is like the same distance as 1 inch of extra height. Like, I don't think that makes any sense. So you have to kind of figure out how to weight those two and transform the space. But the thing with latitude and longitude on points of the Earth, that's not a problem anymore, because what happens is, you have 1 mile north and 1 mile south, or 50 feet west and 50 feet east, or versus 50 feet south. Those are all basically the same distance. Someone's going to tell me north and south, or east and west, are different distance. Well, 50 feet is always 50 feet. We'll take it at that. Like, points, latitude, and longitude is always complicated. So you could see where, Foursquare gets its data from people checking in. And so I can see, well, if the 20th closest people checked into this Starbucks, then I'm probably at that Starbucks too. So I'd love to hear what you think about the nearest neighbor algorithm, and about argument by analogy in general. Next week I am talking to Mark Weiss. Definitely check out my interview with Mark Weiss on his podcast, Using Reflection, which is out. It's on my website, localmaxradio.com again. And I'll be talking to him about what it's like to interview different engineers, and maybe get some tips on interviewing engineers. How do you get that good information from engineers without, what's it like to interview engineers versus other things? And we'll also get an update maybe on data engineering in general. So looking forward to that. Looking forward to some more solo shows, getting a little bit better at this. Have a great week, everyone.